Hello, everybody. Welcome to this webinar titled The Ideal Approach to Application Modernization, Which Way to the Clouds. The host of today will be Sam Vanhoutte. Sam is a CTO at Codit and Microsoft's most valuable professional. He has been working at numerous customers, helping them to determine the best way to modernize their applications, so he's best placed to give you his insights. If you have any questions during this webinar, don't hesitate to ask them via the Q&A window. Some will take these at the end of this webinar. And with that, let's get started. Over to you, Sam.
Okay, thank you, Francis. And hello, everybody. Thanks for joining this webinar. So as Francis said, I'm a CTO at Codit. And in this webinar, I'll share different topics on application modernization. First, I'll start with why modernization is a requirement for a lot of our customers. Then I'll spend some time on the different strategies that you can take to approach your existing applications and modernizing them. And of course, at the end, I'll wrap up with some overviews of different services and patterns that we see in the cloud, and where cloud is really helping customers to modernize their applications. Okay, so one of the main topics that we see is that every company is becoming a software company. Companies that used to have machinery and just looked at IT as an internal thing suddenly start to realize that it's not products that they have to ship anymore. They suddenly have to ship them with software and services. And that is something that for a lot of customers becomes challenging. We've seen that in energy customers, where instead of just shipping ventilation systems, now suddenly they want to have them connected. You see the same things with transport and logistics, where they want to have the fresh goods monitored, for example. So all these things where they just were having an internal operational company now results in they really become a software company, and that's almost for every company that is willing to make a difference nowadays. What we also see is that connectivity and integration, they are really key in building these modern apps. So we see that data has been collected at customers and has been stored in silos and locked up quite a bit. And if you can open up the data, then you can really start mixing and matching the data, making sure that you make the data available and new insights available for your partners, for internal applications. And it's all about extending existing applications and automating these things. That's what we have been doing, of course, for a long time with Codit, connecting and integration. So that's of course where we believe that if you start from there, from the heart of the integration landscape, that you can really open up for modern cloud solutions. The next thing is, of course, that we see that every type of application that we have been building in the cloud, has always been about data intelligence. So being it an Internet of Things program, was it a data platform, was it a modern cloud application providing new services to customers, everything was about data intelligence. So it's collecting data, it's getting insights, and it's of course not just looking at retrospective and historical data, it's also about enriching the data with unstructured data, with unstructured documents, and predicting and preventing things at the same time. So all these things really drive cloud applications today. Other things that are triggered for application modernization is, of course, things that run in the existing data centers. You see that there's two motivations. You either want to have existing applications that you want to breathe some new life in. At the same time, you can have legacy applications running that you want to extend with some new functionality because the business requires that. So we see that things happen with the cycles of maintenance, let's say, where data center contracts expire, or software becomes end of life, or has to be replaced with new licenses. Think about the traditional server software that you might have running in data centers, and these really urge customers somewhat to think and rethink on how they approach their application landscape for the next years. Same thing that we see is that customers want to deliver much faster, and they want to add features and functionality because competition is requiring to do so, and of course their customers is requiring to do them so. And that of course enables new business opportunities. But in order to do so, you have to make sure that you can ship fast, that you can have reliable changes, because we all know the organizations where customers are very hesitant to touch existing applications or existing logic because of, they are locked up in a monolithic application where people are, very hesitant to touch them because of all the risk that comes with it. The next thing is, of course, that some applications have been very successful in the past years, somewhat too successful at some points where the scale of the existing design is not suited anymore. So there's more capacity needs. Sometimes also compliance is required where data has to be, for example, stored for much longer period in time, and data grows way too much. So all these things drive customers into the cloud. Same thing happens with the software end of life, the hardware end of life, and potential security threats of customers that have been compromised in their own data centers, where of course the cloud is typically giving a good answer on the security things. So this is a few of these triggers that we believe drive application modernization, and we see that there's two motions. You either have the migration, where it's more about making sure that you run the existing applications on an infrastructure, on a different infrastructure. At the same time, you also have modernization, where you use more cloud native functionality. And of course, there's different ways to approach that, and I'll talk about that in a few slides from here. The typical challenges that we see in application is on three levels. And very high level, you can say that an application exists of code that is combined with data and state, and all of that is being run on an infrastructure, on the compute, let's say. So what we see is that with code, it's important that whatever has been built, that it is resilient to errors, and that it is of course built to scale much better. What we also see, and that's what I mentioned with the monolith applications, is that sometimes it's very hard to update features, to add functionality on existing code bases. So that also is something that if you change code, if you do refactor, if you do a redesign of certain things, you can really make sure that you can have the agility that customers need. And of course, with data, I think I mentioned it at the same time, where data is growing, data has been locked up in silos in different databases. We see that our customers really want to have data being opened up, for new insights, for new applications, and for new scenarios. And what infrastructure boils down to is really the fact that we see that, of course, customers are not moving from one day to the other into the cloud. So we see that hybrid integration, hybrid scenarios where some data is still residing on-prem for whatever the reason, but of course new functionality is being run in the cloud. And we see that these applications in a hybrid scenario really require advanced monitoring and advanced deployments. And the good thing is that since we're using the Microsoft Azure cloud, that Microsoft really takes the hybrid design quite serious. And that also puts them at first party cloud for a lot of enterprises. Especially what I would recommend, if you haven't seen the announcement, is that you have a look at Arc, that actually allows customers to leverage the Microsoft Azure cloud to monitor, to manage, and update any type of application that is running, not only in a Microsoft cloud, but actually in any cloud and any deployment, either on the edge or in your own data center. And that's really quite powerful. With all the challenges, really should be tackled so that we can release faster, that the software quality is being improved, and that, of course, we are not afraid to have new features deployed and bugs being solved. What we see is that applications also change. We see different front ends being used sometimes. It's not just the fat client or the web page. We see that the same functionality towards end customers has to be offered, for example, through bots, through apps, through APIs, sometimes even for B2B customers, and of course through the existing map. All of that is typically using the same backend, but with different channels. And that's quite an important thing. You see also that the data is really driving things in applications more than it used to be, where applications were mostly just visualizing and reporting on data. We see that data is now being harvested for new insights, and that they drive applications and decisions for customers at the same time. And of course, we see that the scale of cloud is really something that attracts customers for to move towards for their successful applications. And there's different ways to go to the cloud. Of course, the most common one is the infrastructure as a service, where you typically use virtual machines. You have the platform as a service, where Microsoft is doing much more infrastructure work for you, so that you only have to focus on application and data. Then you have the serverless motion, where you even don't have to think about scale, because it's at least a promise that things happen for yourself. And SaaS is where we know that you're just renting or paying for a service with a subscription fee, and all the application logic is done for you. So what we see is that with the existing apps that you have on-premise, we know that they will remain there for a while because you will not move the entire portfolio at one time. The risk is sometimes too high, or the workload is too high, so you have to pick your priorities. And what we also see is that some applications are typically focused on lift and shift, where you have whatever, you take whatever you have in your data center and you just move it into the cloud on a different infrastructure, but without touching too much of the code. And of course, then you can start optimizing for cloud. And if you really want to do things in refactoring, you can start modernizing your application. So optimizing for cloud will allow you to better scale, and you can enhance parts of the application. But if it's a real strategic application and you look into modernization, you can really start thinking about refactoring and modernizing the application instead of just tweaking a little bit here and there. So what we see on the top is that you typically have, on the three left boxes, you typically have not a lot of code changes, where you have the right box is all about big refactoring things. And you can, of course, you don't have to walk through all these stages. We see customers, like you see at the bottom, taking their existing app, totally redesign it and rewrite it from scratch, so that it embraces all the cloud native functionality. Where some customers pick for another type of application, they go just for a lift and shift. And strategies for that really can have an influence based on these things, where you say, we leave typical legacy applications that we want to phase out, we just leave them on-prem, because we know that they are not here to stay for the next 5 years, for example, so let's not focus on these. Then, as I said, the lift and shift, that's where you say, okay, we want to move into the cloud without rewriting things. We just know that we don't have to invest in hardware and things like that, because the hardware is end of life. The only thing is that we see is that if you do a lift and shift, that it is not necessarily a step for the next thing, and that we see that customers sometimes just stay there and they don't move to the right phase, so they don't really embrace or benefit from the full cloud advantages. But that is perfectly okay for some operational applications in quite a lot of scenarios. If you really want to have scale enhancements, that's where you want to have cloud optimization, as I said, where, for example, security could be interesting. But if it's all about your strategic applications, that's where we believe that really adding new functionality, sometimes rebuilding parts or the entire application, is really driving the most benefits. But you will not do that for all the application landscape. That's typically where we see that it's the ones that are the most strategic and typically add the new business scenarios for customers. I won't talk too much about this one, because I think this is a very common known overview. But where you want to be is that you want to focus on applications and data, and as less as possible on things like middleware, virtualization, servers, and networking. And then the choice becomes between platform as a service and software as a service. So if you have to choose between these two, it's more of a build versus buy decision. And again, what we see is that software as a service is something that you can go for if it's typically something that helps you in operational running your operational company. With platform as a service, that's where you build. And what we see customers going for platform as a service is really in the services that they want to offer to their customers, the things that are strategic, that are really their own product. That's where platform as a service comes in. And of course, then it's all about mixing and matching these different components. You want to build a scalable solution. There's a ton of services in the Microsoft Azure platform. They even don't fit on one single slide anymore. But what we see is that instead of having systems to manage, now customers become product companies for these type of applications. And they really have to think about products. So they have to think about roadmap, about versioning, about how to release into production and things like that. And that's a total different approach than just looking at internal systems in a data center. So you have to think about adding new features. How frequently do we update? How open do we have to be? Do we have customers or business partners that want to have extensibility options through things like webhooks or event handling and so on? So all of that is quite important to focus on. And infrastructure is no longer something that you separate from the entire application. Typically, the infrastructure becomes part of the application, at least in the deployment. So the infrastructure is actually something that you define and configure instead of buy and install. And that's a big difference from what we have been seeing in the past. Then we have 5 different patterns to move into the cloud, or that help customers moving into the cloud. As I said, it's all about infrastructure, data, and code. So the things I'll talk about is how containers can help, how microservices have helped us and our customers at several opportunities. Then the data lake is an approach that I'll dive into because it really opens up for new insights and new solutions for your business applications. And then, of course, everything around serverless will be mentioned. As the 5th one, I will take DevOps because that is really the way how to approach these modern applications. So the first one is, of course, container technology. The good thing is that everything is moving into containers. Where 3 to 4 years ago, the thing was quite new for a lot of customers. We now see that customers really embrace it. Organizations are deploying existing applications as containers. And the good thing is that they're really they run everywhere. So you can have, if you take an existing application that might have been hosted on a virtual machine in the past, if you can just move the code into a container, all the operating system overhead is being stripped off. You don't have any dependency because all of that is abstracted on the infrastructure, and you can just deploy the container and then define where it has to be running. So it can run in a Kubernetes cluster, for example, but it can run as a standalone module, and it can run on the edge, it can run in your data center, it can run in the cloud, and actually in any cloud. And all of these things really help without too much effort. So it's a small effort, but you get big gains in the deployment. And of course, all of that is being combined with CI/CD, and with that I mean continuous integration and deployment, because you can now suddenly become provide versioning for your deployments. Where in the past you had a virtual machine, and that was it. And now you have an image that you can reuse and deploy at several different applications, and you just configure it in a different way. And that's something that really opens up for interesting scenarios. Then this is the one that really is quite interesting on the modernization, where you do redesign of the application. So we know that a lot of applications have been started as a monolith, and there's nothing wrong with that, to be honest. And there's perfect good scenarios and a perfect good fit for monoliths in some points where you don't want to over-engineer. You want to ship something quite fast, and you expect things to run and to be deployed as one unit. But at the same time, when we start using or you want to scale out the monoliths, as you can see on the top image, then you have to scale and deploy the monolith 4 times. What we want to do with microservices is what you see at the bottom is that instead of having the app as the unit of scale, you want to split up the app in different services, and you want to scale by the service. So there might be one service in the application or in the system that you have built that you want to have 4 instances of, like the orange one, where there might be other ones that you can just run as 2 instances. So you can start scaling much different in a much different way. What is interesting that these services can become independent from each other. So people can work on one service. So you can have a service that is being maintained by one team and a service that is maintained by another team, and they can have their own independent roadmap. And the only dependencies that they have is, of course, the contract that they speak to each other. And there we see that customers typically, if they go with this cloud native approach, that they go for platform as a service, unless could be that if they really want to have more control on the fine-grained scale and networking capabilities, that they might say, okay, we use the containers like I mentioned before for the microservices, but we run them on things like Kubernetes and so on. API management is really adding a lot of value for us because it allows you to start carving out some functionalities of the applications. And so we've seen customers with large applications like an identity provider in Belgium, where they have a lot of different components in their application, and they want to carve out the ones that are most prone to scaling needs, for example. So the front-end facing services, they were moved and redesigned as microservices into the cloud, but all of that was shielded with API management so that it acted like a routing facade to totally hide all the internal implementation logic and versioning things. What I would do is also a little call out for a full session that Tom Kerkhove gave in November at Ignite. And so Tom is an architect at Codit, where he really presented on API management and on how it could help building these microservices and how it can do it. So you can really click on this link to follow up. Then the interesting one is the data strategy. What we see is that applications, machines, systems, they really have a lot of existing data, and these apps run in whatever existing form factor. But if you start adding integration with it, so you think about the data streams where you have events being collected and they all stream into a central data store, you can also set up traditional ETL type of batch integrations. But if you start unlocking the data from existing applications, and I really say applications, so multiple ones, you use then data pipelines and scheduling, things like Data Factory or Synapse, which was announced also at Ignite. Then you can publish these things into a data lake, and data lake is a concept that is becoming very popular, because what we see is that if you store all the data that you have, you know that if you want to do intelligent data science projects in the future, that it's all about having data available. And no one can do a machine learning or an artificial intelligence project without having decent data of the historical data. So that's where we see that as soon as customers can, instead of keeping the data on premises in their own data stores, if you synchronize everything into a central data lake, into the cloud, where data is much cheaper, that you prepare yourself to have the raw data collected, harvested, to result in curated data. And the good thing is that once these analytics and predictions happen, that you can offer new services, new scenarios on top of that data through APIs again, like you see. And you can not only build new applications, but at the same time, you can also have the existing applications enriched with the insights that you have collected in the cloud. So you take the data out of the applications, and you really think about your own data strategy and your own data approach that you see decoupled from your applications. And customers that are doing that are really successful in driving these modern type of applications and scenarios. Then serverless is, of course, one of these interesting hypes that the promise is there that you only have to focus on the code and everything else is managed by the cloud provider, in this case Microsoft, of course. What you can see is in this scenario on the bottom is that we actually, on the left side, we have an existing application, and we actually did not have to write or touch anything on the left side. So we could keep the legacy WCF service that is actually talking SOAP, if you remember that, with an ASP.NET website. And what we said is we just leveraged the Azure Event Grid that is in the middle, that was just reading on application database. So any change or any update that was detected was taken from that and published as an event trigger. And then on the right side, in the cloud, we could use all these cloud native capabilities. In this case, you could see logic apps and cognitive services, for example, that were just opening up for new applications where, based on translation, a customer email was sent. And that is done without touching the existing web application. So this is something that we see also quite interesting, where by just connecting and extending existing applications with these integration points, you can really leverage cloud without having to rewrite everything on the left side. And then you can still move over time in a phased approach. Okay. What is important is, of course, that you want to have everything shipped in a very fast cadence, that people are really working together. So DevOps is all about making sure that the developers and the operations work as a team, and they use the same process and the same tools. And of course, we leverage GitHub and Azure DevOps for that. And the biggest gain that we see at customers is that the improvement of quality, because of testing and integrated peer reviews and so on, becomes much better. And we see also that customers and teams are no longer afraid of de-deployment. We all know the customers and the organizations where deployments were planned like 3 deployment windows per year, for example, and everyone was really looking forward to that. They had to plan, they have to make sure that everything was ready for that, or they missed the deployment window. If you can change the culture and the fact that you can deploy different services, different functionalities, independent from each other and much faster and a higher cadence, then you get so much more value and also so much more trust at the same time. So that's really where we see DevOps being helpful. So to wrap up, it's not all about changing existing applications. It's also about building new applications, of course. So the good thing is that for these new applications, you don't have the legacy to cope with. And you can go with native PaaS from the beginning, where again, for the infrastructure, the data and the messaging, you can pick your specific solution. So all of that is really something where you can help with. If you want to pick microservices versus Kubernetes, if you want to go for data lakes versus Cosmos DB for your storage, and quite often we see both of them used. And of course, messaging is important, where API management, decoupling through Event Grid, and so on really help you in delivering these solutions. And all of that combined with DevOps. And one of the customers that we worked with has been doing that, where they said, okay, we want to build a total new service that is actually disrupting the insurance industry, where they say, okay, we want to have a multi-tenant application that allows people taking the plane to take an insurance based on flight delay. So you can say, I want to be paid whenever the flight that I have to take for my important business meeting gets delayed, for example. And they are really handling that. And the good thing is that all of that is automated, and all of that is 100% in the cloud. And it starts small, but it can scale big. And that's the good thing, because of the microservices that we talked about, because of the fact that they have several teams, different teams working. One team is on the artificial intelligence for the predictions, where the other team is handling the payments, and another team is monitoring flights and so on. It really helps in making sure that the applications really evolve as a product. And that's a big change for that company, where we were helping them at the same time. So if you want to have data modernization and application modernization done. The good thing is we can help. What we typically offer is a modernization assessment, where we can do system reviews, look at the different applications that you have, look at how the applications are being used in your company and how strategic they are for the future. And based on that, of course, we will come up with a solution architecture per application, a migration strategy or a modernization strategy if you want, and of course a scope and an estimation. If you want to have the project done, you know what you can expect. And this is something that we offer as a call to action, where we can help you in I think a 2 or 3 day assessment based on your needs, coming up with this deliverable. Okay. I think we're a little bit at the end of this talk. I'm not finishing or opening for Q&A without talking about these takeaways. So I think it's important that you pick the right strategy for the right application that you have. But if you do it right, I think the modernization should really drive benefits so that you can have much more trust in deployment, so much more flexibility and agility, that you're ready to scale with the success of the application. And the good thing is that you should be able to focus on functionality rather than the infrastructure that things are running on. And by doing that, you will really isolate the responsibilities and functionality from each other. And that's something that will result in a cheaper maintenance, so a TCO of the full solution. With that, I'm opening up for questions, and I already want to thank you for attending this webinar. Thank you.